Let's get this started. How's everyone doing? Yeah, we awake? Nice to see everyone. Everyone come on in, don't be shy. We have lots of seats up here up front in the middle. How's everyone doing? Good. So welcome to another React meetup in New York in partnership with Use React NYC.
Use React NYC and Real World React out of San Francisco, California.
Yeah, happy to be back in New York again. I always love an excuse to come to this city. My name is Benjamin Dunphy, and I work at Real World React, who also organizes Reactathon, the San Francisco React Conference. We provide training for companies, in-house tech consulting, as well as marketing consulting. Everything from marketing to DevRel to full service conference and event production, if that's your thing. As I mentioned, I also organize Reactathon, which is the San Francisco React Conference. We are coming back on May 2nd and 3rd of this year. And we just published the full schedule, so you can check it all out at reactathon.com. I encourage you to check that out. We've been around since 2017, and the production value just goes up every year. We're very excited for it this year. And if you've ever been to San Francisco, you know that maybe our downtown isn't the greatest right now. It's not in the greatest state. But we're in this lovely neighborhood called Pacific Heights. It is the most posh and most beautiful neighborhood of San Francisco. It's right next to Japantown, right next to two beautiful parks in Pacific Heights. So very lovely location, incredible lineup. I encourage you to check out the schedule. And we'll have some discounts for you that I'll email to you after the meetup. But I'll turn over the mic to Donovan to introduce himself as well.
Sure. I'm Donovan West. I'm the coordinator for Use React NYC, which has been around 2019 or ish, something like that. I've been part of React community in New York even before that, so for a long time. Some of you may know me from American Express, where I was a DevRel. I ran the meetups there. We had what's a great facility as well. This is an awesome facility that we have here at Yext today. But and so this is why we're back here. What, just a second time here?
Yeah, we were here last summer.
Yeah, it's beautiful. I recently joined a company called Daffy, which is a charitable giving app, and I really enjoy that. It's a stack. It's what am I trying to say? Remix. It's a remix stack. That's what I'm trying to say. So I'm in the React community there, and let's see. Yeah, and I'm really happy to be here with Ben again for this React meetup.
Yeah, I'm happy to be here alongside you. And we have 4 sessions planned for you tonight. We got 3 talks, and we got 1 fireside chat. In our first talk, this is not the introduction yet. We're just going to provide you with an overview, is Aaron Pavlick, who's right here from Yext. And he's going to give a talk on streamlining modern web development, building high-performance static sites with Yext.
And then we'll have Ben Holmes from Astro, and he's going to talk to us about opt-in design, a new era in web development.
All right, and following that, we're going to have Paul Butler, former Googler and startup founder at a company called Drifting in Space. That's driftingin.space. Incredible URL, by the way. He's going to be talking about how multiplayer apps don't have to be hard. So that should be really interesting.
And then lastly, Ben is going to have a fireside chat with Hussein Jirde from the Chrome team to discuss his work on Project Aurora.
How many of you have heard of Project Aurora? Show of hands. All right, we're going to dive deep into that then. You're going to be experts by the end of this. All right, so the quick protocol here, we are going to have 3 talks, then the fireside chat. We won't have any Q&A for all of the talks, but we will have some time for Q&A on stage after the fireside chat with Hussein. So save your questions, write them down. If you have questions, we are going to have about an hour, maybe an hour and a half, depending on how much time has passed, of networking right outside there, right behind you. Okay, so let's get into the talks. I'd like to invite Aaron up here just to get set up, just so we can streamline this process. I'll go ahead and unplug this for you. Okay. So he is a developer advocate, developer evangelist, right here at Yext. I mean, is this office not just incredible? Can we get a round of applause for Yext? And he's here to introduce a unified platform with all the benefits of composable architecture. So please join me in welcoming Aaron Pavlick, everyone.
1 second to get set up here. Let's see, enter full screen. All right. Hi, everyone. Like Ben said, I'm Aaron, and I'm a developer evangelist here at Yext. And thank you all for coming out. We've done a couple developer meetups here, but I think this is the best turnout we've had. So thank you again. And if anyone else is, a meetup group organizer in the area, or if you're just, want to chat dev stuff, feel free to talk to me after. We'd love to host future events here as well. But today I'm here to talk about building static sites on Yext. But before I do that, I want to step back in time just a little bit to kind of the origins of the static web and just talk about how we've come full circle here in 2023. So first we had Web 1.0. Which was basically where developers took static HTML files, threw them on a server, someone put in a request, and they got that page back in response. So you had the early blogs of the 90s, what I like to call the read-only web. Then we started to see some more dynamic websites with the rise of server-side framework, HP, and we started to see some CMSs like WordPress. And if you're not familiar with what a CMS is, it stands for a content management system. This is a way for you to store all types of content on the web. So you started to see way more content. The web got a lot more robust. And a ton of the internet is still powered by WordPress to this day. But then we started to see client-side rendering in single-page applications. And I know many of you out here have probably been developing on the web a lot longer than me. I'm probably skipping a lot of stuff in between. But we saw the rise of Angular, React, and Vue. And the advantage to frameworks like these is with client-side rendering, you're getting a lot of the same performance you would expect from a desktop application, but you're getting that in the browser. We're shipping a ton of JavaScript to the browser. And yeah, you get more interactivity. The problem is that not everything should be a single page application. Let's say you have a e-commerce website with a huge product catalog, and when someone searches for shoes, you want that page to come up first. Well, single page applications don't do very well with search engine optimization. So that's because they have slower initial load times, limited crawlability, often limited metadata. So we're back to static sites. And now developers don't necessarily have to upload individual static files, individual HTML files. You have static site generators like the ones you see here. And you also have headless CMSs, which unlike WordPress, where you have your content and your UI tightly coupled, you could take a headless CMS like one of these and a static site generator like one of these, and you could create kind of you could mix and match to create your own static website, along with having a lot of more interactivity than you used to get with the static web. You can still have some JavaScript in the browser to add some of that interactivity that you get from frameworks like React, Vue, and Angular. So you're maybe a freelance dev, or maybe you work for an enterprise, and you need to build a static website. So you're going to start with picking your headless CMS. You're probably then going to pick a static site generator. Then you need some code to fetch data from that headless CMS and throw it into your page, basically. And then since it's 2023, you need a hosting and deployment service that is serving your pages at the edge, along with support for serverless functions to add a little bit of that back-end functionality. So that's kind of the basics to get up and running. But as your content continues to grow, you're likely going to want to add search. And since you're adding content all the time to your CMS, you need to keep that updated in your search index. So you probably need some kind of process, an ETL, to update that index each time your content is added, edited, or deleted in your CMS. You also will want incremental site regeneration. So you're probably going to need a webhook that triggers whenever the same content is updated. And you're going to want to regenerate that specific page on your site rather than building the entire website. So there you go. There's kind of your architecture for building a static site in 2023. Obviously, there's a lot of other things I haven't covered here, like maybe auth, or maybe you're an e-commerce website and you need something like Shopify. But kind of the basics here and what I want to talk about building today. So like I said, that's a lot of vendor dependencies and potentially a lot of bills. So what I want to get into now is the Yext platform and a quick demo on how you can consolidate a lot of those vendors into one platform, but maintain that composability that you get with building websites today. So I will get into my demo. And what I'm going to start with is over here in the web page, a single static page, not this one. This one here, make sure that, yeah, so running locally, I have a static page for Governor's Ball that's this summer in Flushing, Queens. Actually, I'm going to refresh the page here. I changed, yeah, there we go. Governor's Ball Music Festival with some basic fields like the name, the date, a description, a poster for the event, some basic fields. And I'm managing this data in Yext's headless CMS, which is called the Knowledge Graph. So I'm going to head over to the Yext platform. And there you see my Governor's Ball entity. So I should take a step back and say that all content in the knowledge graph is stored as what we call an entity. And this particular entity has some basic fields like name, description, a date, time, that poster you saw. But it also has some linked entity fields like venue and artists. So rather than just being strings, these are actually links. So if I click on this, this takes me to Flushing Meadows Corona Park, kind of a poorly named park in my opinion, with an address and a map marker. And then that links back to the event I was just on. So I could go back. And then we see all the artists that are performing at Governor's Ball this summer. So I could click on Lizzo, for example. And I see some different information about her, including a Spotify ID that I'm going to use here shortly, along with some genres and photo gallery. So those are all the fields that I have on my static page. But how did I get those fields onto the page? So for that, I'm going to get into the Yext Pages framework. So let's close this. Oop. I don't remember if I want to save this or not. I'm going to say, we'll say save. OK, so in my templates folder, which is a pretty important folder, I have a couple different files. But today, I'm going to look at the festival template. And what I want to highlight here is my template config. In my template config, I have an object called stream. And stream is the vehicle by which data is taken from the knowledge graph and injected into my templates here. So I've specified a filter called music festival. And so that means that every music festival in my knowledge graph, right now I only have one, but if I had 100, they'd each be represented by this one file. I've then specified the fields I want to pull in from that particular, from every music festival. So some of the names some of the fields I highlighted earlier, like name and description in that poster I had up there, along with some linked entity fields. So I've got venue, address, artist photo gallery, some of the stuff you saw on the page. So I'm going to walk through, well, let me pause here and say some of the things that I didn't mention, which include auth. I didn't have to worry about authenticating with the knowledge graph, and I didn't have to write any client API code to fetch data from the knowledge graph. All I had to do was specify this template config here. And then if I take a look at one field, like name, and walk down into my actual component code, I have this document object here. So I can pull name from document and then throw it into an H1 tag here. So that's probably the most simple example I have on this page. But I'm doing something similar with all the other fields that I'm pulling from the document object, just throwing them into React components. So that's the Yext Pages framework in a nutshell. And just to go back to the page real quick. So let's say I want to deploy this. What I'm going to do is go back into the platform. I'm going to go to Pages, All Sites, and I'm going to add a new site. So I'm going to connect to my GitHub account, continue, and authenticate. And we'll just call this the React meetup site. And I'm going to select my GitHub account. You see some other folks who's, I'm seeing other GitHub accounts because we have a bunch of GitHub accounts in one organization, but you wouldn't see something like that. And then I'm going to select the repository I've been working out of. And then finally, I'm going to deploy my master branch. So as soon as I click deploy, that's going to trigger a build of my site and start generating individual pages for all the entities I've specified in my template config. In this case, it's just that one music festival entity. But again, I could specify a different template for all different entity types. Or I could just have the one template and generate pages for 100 or 1,000 different music festivals. So that covers the basic. If I go back to my slides here, I've basically covered the middle section here, from headless CMS to static site generation to deployment at the edge. But now I want to add a little more interactivity to my site. So if we head back here, I've basically split up this page into two sections. So I want to see all the different artists that are performing at Governor's Ball. So I'll go down to explore the full lineup. And here I'm seeing all the different artists that are going to be performing at Governor's Ball this summer. And maybe I want to search on just the hip hop artists. So we've got Kendrick Lamar along with some other artists, or maybe I want to search on electronic. And I see Diplo, Sophie Tucker, some other popular artists. And maybe I don't know any of Odessa's music. So I'm going to log in with Spotify. And you were supposed to see a Spotify authentication screen, but I forgot to delete the cookie. But what happened was I basically logged in with Spotify, grabbed a token, and was redirected back to this page. So now I can use that token to fetch the top artists. I could click on an artist. I get a visual representation of the audio data down here. And I could click play and start playing some music that you may or may not be able to hear. But, well, I can hear it. You can't. So yeah, let's talk a little bit about how I made this happen. So with the Yext platform, all of your data that's in your knowledge graph can be instantly indexed into a search experience. And then I could use that search API key with the Search UI React library, which is a series of React components specifically designed for Yext search. So let's go back to the platform real quick. We can see that my page was done building. I'll come back to that in a second. So here's my search experience down here, but let's say I wanted to create a new search experience. I would click on search, see all my experiences, click add experience. I'll call this React Meetup as well. Continue. And I only want to index my artists. So once I create that experience, everything is instantly indexed. I didn't have to write any kind of process to take the data from my knowledge graph and throw it into something like Elastic. I could start searching right away. So I could search for hip hop and see the same hip hop artists that I saw on my page. In experience details, you have your search API key, which I'm using with the Yext Pages framework, but I've also used with React Native and other frameworks as well. So you can use the Yext search API in your framework of choice. So if I go back to my website, I want to talk about how I got my Spotify token. So what's happening here is when I clicked login with Spotify, you would normally see the login with Spotify authentication screen. I would grant my application permission to Spotify to get that token back. It would then hit my redirect endpoint where that token is then returned to the original place where I asked for it. So I did a pretty poor job right there of explaining OAuth, but usually you would need an OAuth server, some kind of backend to handle that for you. But with the Yext pages framework, I'm able to add a folder here called functions. And so each one of these files represents a different HTTP endpoint. So if we look at login, for example, where I have some to-dos, still some work to do on this. But basically, this is what's powering that initial auth screen that I wanted to show you. And then once I authenticate, the token is sent back to my callback function, which then redirects back to my page. In an hour, I'll need a new token, so I'll use the refresh endpoint. And I'm actually compressing the audio data. There's a Spotify audio analysis endpoint. There's a really awesome guide I found on Medium that shows you how to basically take the Spotify audio analysis data and then compress it into a string of numbers. And then you can create a visual representation like the wave that I'm showing down here. So that's an overview of how you can add some more interactivity to your Yext pages site through the power of search and serverless functions. Now, the last thing that I want to demo, I will go back to the platform here. And as I mentioned, my site should be done building and deployed now. So if I go back to React Meetup, deploys, and I didn't create a homepage for this app, so you'll see just static page. But I need to go to the exact URL, which is at, this is at localhost. So you need to grab festivals, and then the ID of the particular festival. Go back here. And so I see the same page that I was seeing locally. But let's say, I don't know, maybe I want to provide my users like a little more information about Governor's Ball Music Festival. I'm going to go back to the platform. I'm going to go to the Music Festival entity, click on Governor's Ball Music Festival. Then I'm going to go to the name, and let's just add in Flushing. Well, I'll just leave that typo there, Queens. And I will click Save. Then I'm going to go back to the site, not back up. Go to Deploys. And you'll see this data updates link right here. So you can see that at 7:04, there is a data update, which was just right now. So I'll click on data updates. If I scroll, once these logs load, I'll click on view details and then head all the way down to the bottom here. I have a lot of data linked to this page, which is why this is so long. All the different artists you can see are linked to the music festival, and that's all the data you're seeing here. But at the bottom, I have the name field that I changed from Governor's Ball Music Festival to Governor's Ball Music Festival in Flushing, Queens. So I only made an update to one entity, therefore only one page got rebuilt. So if I head over to the production site, make sure this is production, yeah. You still see Governor's Ball Music Festival, but if I click refresh, you see the update right away. And that's what we call incremental site generation, and it's super easy with the Yext platform, no additional code required. So that's a brief overview of some of what the platform provides. If I head back to the slide here, I just want to highlight that even though I showcase some of the products here, Yext has a lot of product offerings, we don't want to get away from developer composability. So if you need to add something like Shopify for e-commerce, or you want to add auth, or you want to take that same data and throw it into a native application. I personally like the Expo framework a lot. Or you could add analytics with something like Amplitude. So thanks everyone for attending, and thanks for listening to my talk. I'll be around for questions, and feel free to follow me on Twitter, hopefully pushing out some more Yext content. And I can also answer questions on there as well. So thanks again.
Thank you, Aaron. Great talk.
Thank you.
Okay. Our next speaker is
Ben
from.
wants to come and get set up.
Oh, yeah. Our next speaker is from Astro, a framework that lets you write React code without shipping any JavaScript, which I think is a lie, but Ben will tell us here in a few minutes. He's going to talk about a opt-in design, how smart defaults guide today's modern frameworks, and how they reshape your workflow. Are you all ready? Okay, awesome. So we have props, so hold on.
Whiteboard the web. You.
Okay, so help me in welcoming Ben.
Yes, well, hello, everyone. It's good to see people in person. I've done virtual meetups, talks, videos for a long time. This is the first in-person thing I've done, so go easy on me. But I'm here to talk about opt-in design, which is a blanket term I'm using for this new age of web development tools and frameworks that we're seeing emerge in the recent years. So first off, to clarify the word design, this is not a UI design talk, although graphic design is my passion, clearly. It is also not a systems design talk. We're not here to talk about design systems or anything of that nature. We're here to talk about API design, so the way that you structure your code and you author it for other people to use. And we're going to try to learn what good defaults really mean when you're trying to build something, when you want to start small and configure your way up into something more complex. And also finding and building the best tools, frameworks, et cetera, for everyone, you, your team, anyone that you're working with. So hoping you can walk away with some tools to like author better code and also find frameworks that match what you're trying to do a little bit better. So first off, I'm Ben. That's my face, but bigger. I am a core maintainer at Astro. That's our actual URL, astro.build. I call myself the CEO of whiteboards. WTW.dev is where I host all my videos, a little preview link here, but I do a lot of content about React, MDX, Astro, et cetera, all 1-minute snippets about these topics. At least got to plug it a little bit, right? And my values, I at least like to put them here. Be caring, be clear, be casual, because technology is a scary thing, so explaining things in a clear way and being a little bit informal and jokey about it is my mentality. So I'm hopeful. This will go to the next one. Looks like as I click the link. There we go. Okay, so first off, React developers in the room, raise your hand. People who use it, beginner immediately. I can't believe it. It's use React. Okay, keep your hands raised. Keep them raised. So keep them raised if you've written code that has done something like this before with use effects. Okay, more hands went up. I didn't even ask for that. Also keep them up if you've Googled something like this before. Okay, so everyone's hands are still raised. If you haven't looked around, no surprise there. And that's because, and you can put them down. You can put them down, that's it. But that's because of sort of a principle that's core to how React is designed, which is that you re-render everything by default. That's an assumption that they make because they want you to develop applications, things that are interactive. And the ethos of that it starts off easy and then gradually gets more hard and complex as you go. So one nicety that React has is, of course, you can recalculate anything that you want because everything is going to rerun as you go. Here I have a shopping cart example you might have on an e-commerce site. Very, simplified code example. But say you have like the quantity of what someone is purchasing and you want that to increment and decrement. And you want to calculate the price based on the quantity that they have in their cart. Well, since React is going to rerun the entire component that state is encapsulated inside of, you can say, all right, anytime this state variable changes, it's going to rerun the whole shopping cart function and rerun this calculated price here. And calculated price is like utility function. So when you update with that text input, it'll change this state, which triggers the whole function to rerun. So calculated price will also come back with the new value to display in the UI. So all pretty simple, right? Where if you just want to calculate one based on another, you just write a new variable and you run your function. But of course, what if quantity is coming from somewhere higher up? Anyone in here might have worked with like Redux or GraphQL or something else that has more hoisted state. If you're dealing with that, then maybe you have a provider that is providing all of that state that you're rendering on the page, passing it down as a prop, which of course means that if the quantity ever changes somewhere down in the UI, it's going to rerun everything in this box. So if this wraps around the cart flyout that is flying out from the side, it's wrapping around your navigation bar, anything is subject to re-rendering. And if you hoisted that state a little higher, you put it in the entire cart provider, the whole checkout flow re-renders when you change your quantity. Or you put it in your classic provider, which is what you end up with global state, where you could have your entire app re-render unexpectedly if you're trying to change something. Specifically with React context is what we're talking about there. And at that point, it's time to break out the use memo hammer, the thing that we were Googling earlier, because you're conscious about performance now. You understand these pitfalls. You read the blog post. So now you decide, OK, Kent C. Dodds told me to wrap it in use memo. So I'll go ahead and do that, list quantity as a dependency to make sure that expensive calculate price function only runs when the quantity is changing. It's not rerunning when other unrelated stuff happens. But of course, you have to be conscious of what you're doing there. And this is what I would call opt-out design, where the React developers assumed a goal. They assume you're trying to re-render everything. You want it to be interactive. And this lowers developer friction as much as possible. You can just write variables, and you know they're going to update. And this hides complexity from you so that you can ship the app pretty quickly, and you know everything's going to be interactive as you expect. But that means you're dealing with the complexity monster later when you learn about how all of this stuff works. So now I'm going to attempt to whiteboard that. This is the most experimental part of the talk. We'll see how it goes. But hopefully, can y'all see the word hello in the back? I'm getting thumbs up. I'm surprised. But yeah, I can at least try to draw out sort of what I'm trying to communicate here, where usually, this can be your starting point. Let me erase the word hello now that we have that. But say you start your application journey here. And you are slowly, working with your team, you're developing features, and you get all the way down here. So the start of it is, hello world. So I guess I'm writing the word hello again. But this is hello, and this is, when you actually ship your application. And there's a lot of things that happen along the way, of course, where you're making decisions, you're progressively adding complexity to the flow as you go, but the friction is going to be really, really light. I guess I'll just stick with a black marker here. But you slowly go down, and then eventually you discover all the complexity that you have, and you deal with the fire of everything going on. My goal was to draw the little, the dog? He's kind of like this. He's saying, this is fine. That you deal with that towards the end of your journey. And that's because you're offsetting the flames or the friction that you're dealing with until it's a little bit too late. You deal with the user metrics, and you need to sort of correct the code that you had. So the sort of spectrum that you have there is, DX is number one. This is your number one priority that you're dealing with. And then when you get down to the bottom, now you've realized that user experience number one. So you go back, opt out of things, and update your performance. So the goal of APIs and the things that you use, in my opinion, should be to sort of flip this spectrum in the other direction, where to start, you're actually trying to be focused on user experience first. So that is your number one priority that you're trying to address. And then when you're going up here, you probably don't want to confront the everything is fine dog right away. That's a lot of complexity to deal with. So the goal of the tool should be start from a baseline and have little sparks of complexity as you go. I'm trying to draw like little sparks of friction that you might deal with, so that you deal with friction, but you're distributing out everything as you go, slowly opting in with more complexity points, and then getting to number one developer experience without losing the user experience side of things. So you can get to the other side of the chasm without a big blow up anywhere in the performance metrics, getting both user and developer experience in tow. that is what I'm going to talk about here with opt-in design. I hope that session went well. Did everyone see it? Can we get thumbs ups if that made sense? Yeah, okay. And we're getting claps too? I love y'all. Okay, so we're talking about here, how can we do this differently? And there's many, many approaches that people have been experimenting with. SolidJS is the one that's interesting to me. This is quoting Fireship, a popular YouTuber that explains things in 100 seconds. It's a declarative JavaScript framework building fast UIs with control over what you're making reactive in your code. I call him the second best YouTuber because I'm on the platform. So this is a React and a Solid component side by side. You'll notice that they're roughly the same amount of lines, and everything is set up in a similar way. Where at the top here, we're importing a utility. It's called useState in React, create signal in Solid, although conceptually here, we can consider them the same thing. Oh, I have a clicker. And when you're working with this for the first time, you might think you can kind of recalculate values the same way. In React, you would just write a variable. So in Solid, you might try to write a variable as well. And I have two actual clickable buttons here. In React, it's going to update the price as the quantity goes, assuming it's $3.99. And in Solid, the quantity updates, but the price isn't. What's going on there? That's because in Solid, you actually have to declare what is computed from other properties. You might have heard of the word compute if you've used Vue.js maybe. But in Solid, they use a slightly different principle. There we go. Where you can actually create a function that is going to rerun every time the price changes. And Solid has a little compiler around JSX in order to treat this correctly. So a function is assigned to Solid. This is a thing that you might need to rerun based on dependencies. And the dependencies are based on actually the sort of chain of reaction that goes on here, where in our text input, this is the source of state variables changing, where when the on input fires, it's going to update quantity, which can then update anything that depends on quantity. But in React, it doesn't really understand dependencies at all. It's just going to blindly rerun the whole function because state was declared here. But in Solid, it's actually granular down to the thing that's being rendered. So it's really smart in saying the input is the part that renders on the page, and quantity is the part that updated. So the only thing I'm going to re-render is the price, which I hopefully highlighted in one of those. I didn't. But because it was able to figure out prices being rendered on the page, it's only going to rerun where the state is used. So price is used, it'll re-render this part of the DOM. It will not rerun the whole function. While React is doing it based on where state is declared. So it reruns the entire thing a little bit more wastefully. And this is part of a whole wave in how frameworks are thinking about things in an opt-in manner. Svelte is one of them, using a $sign to opt-in interactivity. This is a more interesting example because they use very spicy syntax. But in here, variables are just variables that you can reassign. And they use a $sign to say that this variable depends on some other. And it's able to compile away that quantity is a dependency, so it'll recompute this when this changes. And it'll only rerun the part of the UI that depends on it, which is the price component. So this takes me to some core principles that I have around opt-in design, or at least reverse engineering what that means. And there's three components. First one being find the lowest common denominator in what you're trying to build. The second being make complexity easy to add, but only when intended. Don't make it like an accidental foot gun. And stay user first when you're designing that default. It's not meant to be developer first. The real way to be developer first is long-term developer experience, not necessarily the hello world short-term. So digging into each of those, when you're trying to find the LCD, as I abbreviate it later, you're trying to find the simplest use case for the tool that you're building. And in React's example, the simplest thing you could build is just like a static blog or something like that. It's just HTML. There's no interactivity to speak of, let alone re-rendering. So when you're designing an API like SolidJS, they thought, all right, let's not re-render by default and have an opt-in switch, which is a function or a $sign in Svelte, in order to opt in to that more expensive behavior. But it also has to make sense with what you're coming up with. You don't want like a car with opt-in wheels. Like, I mean, the car's always going to have wheels, so you might as well add that as a baseline for the hello world. Developers shouldn't have to do all the work. But you should have just enough where they can add complexity easy. And that takes us to our next one. You want to make it easy to add that complexity. Just add that $, and then everything works as expected. So $'s the example I have there. We'll also talk about Astro in a moment and how it can opt into shipping JS in a very nice way. And this is the opposite of what I would treat other frameworks like React, Next.js, approaches like that, where you start with a kitchen sink of 120 kilobytes of JS, and you slowly code split your way backward when you get the Lighthouse scores back. The goal is to have that Lighthouse score of 100 for that hello world and slowly add things onto it. And every time you add a little complexity, a little JavaScript, check those metrics again and see if you're making the right choice. The point is actually having choice in there. And the third one is staying user first with that default. So a low complexity baseline usually means better user experience just because of performance a lot of the time, sometimes with security vulnerabilities as well. And one example of that, of course, is when you opt in to re-rendering parts of the UI, you got fewer CPU cycles, any number of work that your computer is doing, so low-powered devices, poor internet connections, you'll get better performance down the wire. So if you start with less complexity, you probably will just get there, but at least keep the user in mind. And there's a whole world of examples around it. Just checking the time there. So Deno is an interesting one that I just started playing with, or Deno, as I've learned it's called now. It brings opt-in to permissions in whatever you're building. If you've ever used Node.js, you know that you can just kind of call file system APIs and wreak havoc on a machine if you want to. And Deno, which is from the creator of Node, that's literally Node backwards, or it's not Node backwards, it's like a anagram, is that the word? Yes, thank you. But it is from the creator of that, trying to do a fresh start around what JavaScript on the server could be. And one idea there is making all of the features opt-in. So anything that could be a problem, like accessing your internet, being able to read off of your file system, being able to access your environment variables. Like how many times have you doxed yourself trying to get process.env and then it spits out just everything on your computer? Deno wants to lock all of that down, Deno. And each of these are like the principles we talked about earlier: lowest common denominator, complexity, user first. And I feel like it addresses all of those pretty well. The lowest denominator is someone just trying to build a CLI tool with Deno. They don't need any I/O or network access, so it's good to just shut off their access to that. And it is definitely additive. You start with no flags, add them on, and it's very clear what those flags are doing, so you can't be unintentional about it. And it is user first. We're talking about security here, so the default is going to be the most secure option. The next one is, of course, Astro. Hey, bringing opt-in to shipping client-side JavaScript on your sites. So this is actually an Astro component, which is another templating language. Yes, another one. But it is just like JSX in a way. The only difference here is we got these little dashes instead of using a function wrapper. But in this example, we have just some static HTML that's rendered here. No JavaScript is shipped to the client to render this HTML. It's just markup, rendered server-side or during a static build, either one. And then if you want to add interactivity, you're free to import any component framework you want: Vue, React, Svelte, etc. And you can import it in line and intentionally add a little flag here to say, this ships client-side JS, and I only want that JS to load when the component's visible on the page. So when you scroll down to that component, I want to load React and the like button that we're trying to get. So when they go to our home page, it's 0.js and it loads instantly. You get 100 on Lighthouse. And then when you scroll down to the heavy image carousel, that is when it triggers everything. So you're really intentional with everything that you're adding. And of course, the lowest denominator there is you're building that home page with no JavaScript, and we're trying to make sure that's as performant as possible. And it is additive with what we're trying to do. It's a client directive. It's clear what it's trying to do. And you even have flexibility of when the JavaScript ships. Here I'm saying when it's visible. And it is user first. Core web vitals matter. Low-powered devices are important. So offloading all that work to the server, if we can, is definitely a win. So the last example is a really new one, actually. I've been playing with React server components. I don't know if anyone else has been playing with that. Next 13, a few nods out there. But it's an interesting pattern where they're actually bringing opt-in to data loading or adding loading spinners to whatever you're trying to send to your user. So this example is a component that runs on the server. And if description needs to do like an async fetch to your CMS, to get whatever product description you're trying to display, it will block sending anything to your browser until that CMS data is done loading server side. And then for this bit of information, our reviews section, we decided this is less impact. We don't care if we ship the whole page to the user without the review section loaded. So let's make sure we get that description to them as fast as possible. And we'll put the review section behind a loading spinner. And all that logic will still run on the server, and it'll stream down the update when it's ready with a nice little skeleton as a fallback. You might have seen, like, you know, it's kind of a placeholder where it has some like gradient boxes that kind of look like a review until it's loaded. That's the kind of experience they had in mind building it. And it's definitely a nice lowest common denominator. Your critical pages can be blocking for like all the async requests, no loading spinners here. We're going to get it to the user with good lighthouse scores because everything displays all at once. And it's additive, where, you know, the least complex option is block and load, but the more complex option is dealing with fallbacks. And that's something that is behind the suspense boundary, as it's called here. And it is, of course, user first for similar reasons. We're minimizing the loading in all of the client-side JS that we're shipping to your browser. And we're also being conscious of layout shift. Whenever you have loading spinners, things can shift around while that data is loading in because you don't know how big it's going to be. The loading spinner has to be roughly the size of our review box. So we're trying to avoid that experience where possible so that Google's able to crawl your page a bit better, and so you don't get a bunch of thrash when you're actually loading it on your site. So thumbs up. Do I have time for a demo, or are we at time? OK, there we go. So I have a demo app here on astro.new. If anyone has a computer out, go to astro.new right now. You can try out Astro yourself. I see some people looking down. That's good. Done my job. But we have templates for all sorts of things, a basic site, a blog, doc site, etc. And I'm just going to play with a few of the features there. I have a ready-made one where I've already npm installed, of course. But it'll take you to an online editor. This is StackBlitz, which is a really nice way to just try something without cloning it yourself. And this is a basic Astro app, or an Astro site, I should say. So it has one page, and you can see it's file-based routing, similar to Next.js. It's literally pages. And this is our index route, which is just displaying some server-side, or in this case, a static build of JavaScript in our page, or lack of JavaScript, I should say. And if we go to our network activity, it might give us a whole ton of stuff from StackBlitz, but we can see it's just going to send down these scripts here, but it's not going to send any like JSX. There's no React and React DOM. There's no virtual DOM because there's literally nothing re-rendering on the client at all. This is just a regular server-side template like you may have dealt with, like Liquid, Mustache, all of those languages, but modern, because this allows you to use components exactly as you would in JSX. So it's the same sort of principle there. And we can see we're importing a layout, which is just like any other component. And we're displaying some server-rendered HTML. So of course, we want to look at, this is a React meetup. How do I use React in this thing? I'm not going to use it if I can't. So to demo that, I can actually add React to this, literally by calling Astro add in my terminal. So you can add any known integration or deployment adapter with this CLI. Here I'm going to run add React and also Node, maybe play with some SSR. And when you do that, it'll install packages if they aren't already installed. I already have them. And it'll update your config file for you. So when we talked about that opt-in thing, it better be easy. Otherwise, there's too much friction for me to use the tool. It's not enough payoff. So we made it very low friction. It'll just update your config, import everything, make it a standalone Node server, all of the defaults that you might want, and it'll update your TypeScript config. Yes. Can we get a round of applause for not having to look up TypeScript docs? Yeah. No TypeScript. Yes. There we go. OK. And then when you hit yes, everything is updated. And now you are free to use React in your application. And I have a ready-made like button over here that I'll just paste in. And I kind of wrote this on the fly. I didn't run it, but I'm trusting my React knowledge here. So I have a like button. It's going to update the state, set liked, display that. You know, a simple true-false variable. Probably played with that before. And then we'll go back to our home page and import it. like any other component. So if I head over here, we can import our like button. And if you're using the VS Code extension, you'll get some nice autocomplete. StackBlitz is a little behind the times, so I'm going to manually import this guy. But we have our like button, and we can put it on the page like any other component. So we'll go ahead and do that. And now we see it here. And you'll notice it's not functional by default. And that's because we assume the default that you're trying to build for is 0.js. You're trying to server render an application to send to the user. And if you want to use client stuff, you have to be a little bit intentional of how you want to load that JS. So in here, I'm going to say, I'm going to load it just when the page loads, because it's above the fold, not really a big deal. But now this is going to opt in to shipping React and React DOM to the client. So it's really is that simple. You can use any framework that you want to. You can also hot swap this in your config if you wanted to change from using React to SolidJS, like we talked about earlier. Install the Solid extension. If you want to install Preact, you might have heard of Preact, lower JS alternative to React, you can try that too. Because it's a very agnostic templating language, you can opt into any JS that you want to. But by default, you're just using server-side templating. And the last thing that I'll check out a little bit is server-side streaming, which is something I just realized we support. So I kind of wanted to play with it. So one thing that I'm going to add up here is maybe an async fetch for something. I'm not in Copilot mode, so I can't get a Pokemon API going really easily. So I'm just going to say lazy promise, like that. lazypromise.astro. And this is our way to write scripts. You just write 3 dashes. You can call it front matter if you want to. You can also just call it a script tag. That's literally what it is. And inside of here, I'll do the classic await new promise. I write this a lot. Set timeout res. I think I did that right. This will wait 1 second before sending you HTML. That's what we're trying to do. So let me even write that out. Wait 1 second. And then we'll send it down. Resolved. I'll even make it 2 seconds just to make it a little bit more obvious. And no one's shouting, so I'm assuming I did the code right. But I'm trusting you. I'm trusting you. So I'll go ahead and import that from components as we did before. Lazy promise. And we can import it just like a React component. Everything is a component. And if I render that onto the page, we'll get some pretty interesting behavior, I think, where if we put that in, this should work. Does this render stuff to the page? Yes. Index. Interesting. I'm actually not seeing anything. Odd. OK. Maybe if I do that. All right. StackBlitz is, there we go. Interesting. OK. That's not the most compelling demo that I was hoping for. Dang. OK. Well, it was meant to stream in the like button, and then this will stream in 2 seconds later. So it'll literally update the page in real time, the same way you were looking at like the loading spinner before with React Suspense. We support that on both Node, Dino, Netlify functions, anywhere that you can deploy JavaScript. It's definitely part of the model. But when you're dealing with an online sandbox, things happen, especially with the dev server. So yeah, that is sort of the conclusion of my talk. Thank you, everyone. I hope you enjoyed. You can find me at bholmesdev anywhere. I'm on Twitter, TikTok, YouTube, Twitch now. This is my YouTube channel where I do whiteboarding videos like this. And also, I put together a little React Server Components and Dino demo, since it's really fascinating technology, and it's cool to play with it outside of Next.js to see what the future of React is. You can go there if you're at all curious, or just find the entire slideshow, also bholmesdev on GitHub, so you can look at it over there. But yeah, that's everything. I hope you all enjoyed. Thank you for your time.
All right. Thank you, Ben. Excellent talk. How many of you actually knew about Astro before this talk? How many of you used Astro before this talk? All right, we got 2,
50.
3 in the audience, 2.5. You got your hand up now? All right, so 3 of you. So very excellent. How many of you are going to use it after this talk? All right, yeah. I think we have some converts, Ben. Very, very nice. OK, and actually, if you like that, his boss is actually going to be at Reactathon on May 2nd and 3rd. And I hope you'll be there as well, because that was fantastic. Maybe you can manage a topic
New
table
York?
there.
Or
No. Reactathon's in San Francisco. You got to catch a flight. That's Fred Schott. I think his Twitter handle is like at Fred K. Schott, yeah. Very easy. Semi-controversial figure, but yeah. Well, he's got some spicy tweets every now and then. All right, so excellent talk. I'm really happy to keep this going. Our next speaker is a former Googler and now founder at a startup called Drifting in Space. And he's going to talk to us about multiplayer apps and how it doesn't have to be so difficult to make multiplayer work. And perhaps you too can build a multiplayer app and sell it for billions of dollars to Adobe. Please join me in welcoming Paul Butler.
Hello, everybody. Can I take one of these? Can I take a water? I'm so thirsty. Perfect. Hey, everybody. I'm Paul. I'm a co-founder at Drifting in Space. We do things that have to do with multiplayer, so this is not too much out of my wheelhouse, but the gist of what we do is when applications want to exceed, browser-based applications want to exceed the performance ceiling of the browser, we have infrastructure for that. Turns out that a lot of applications that want to exceed the browser performance also want to do multiplayer, because multiplayer is cool these days. When I talk about multiplayer, this is kind of an example of what I'm talking about. This is a demo that we built with some of the techniques that I'm going to be talking about in this presentation. Depending on your point of view, this is either low-budget Minecraft or metaverse that actually works. So this is, yeah, basically this is three of us in this shared 3D world. It's React 3 Fiber happens to be the framework we use for this. And then the multiplayer is, well, we'll talk about. But yeah, this is under 250 lines of code, which is, I think really says a lot about React 3 Fiber as well. But only a few dozen of those lines are actually the multiplayer. So one of the things that I really want to drive home tonight is that multiplayer, if you Google it, like if you look into what people are talking about, there's CRDTs, you go down these rabbit holes, but it doesn't have to be complicated. But the first piece of complexity kind of creeps in when we realize that browsers can't talk to other browsers, or an application running in a browser can't talk to another application running in a browser, at least not without WebRTC and some other fancy stuff. So generally, we don't have this assumption that we can just talk to a peer and transfer state. What we can do is spin up a server that both parties can talk to. So each instance of your application can open a WebSocket connection to a server that you're running somewhere. And you can kind of treat that like it is connected. Like from each client's point of view, it's like they have a WebSocket connection to the other client. So this is just assuming that this server is basically just a dumb relay. It's just taking a message, sending it to the other client, getting a message back, sending it to the other client, and sending them back and forth. And we can generalize that to multiple clients. So multiple clients can sort of all connect to the same server. And you can almost imagine it like a group chat. Like all of these applications are kind of in this group chat together. They send out messages. They receive messages. And they have this kind of log of message history. And when I'm talking about these group chats, each server can kind of host multiple of these. So each one is you can kind of think of as a room. You can kind of think of it as a chat room in the group chat analogy. But they operate independently. So each set of clients who's interested in the same document state, program state, game state, the same things in general, they can talk to one room, be in one group chat. They can share that server with another group chat, but there's no overlap of who's talking to who. You can also split that room across servers. Have multiple rooms that are on different servers. What you can't do is have clients talking to different servers. And that's really where things can get complicated. This is from a blog post that Figma did a while back on their architecture for multiplayer. One of the things that's notable about it is that even back, this is a few years old now, they were doing this kind of routing where if you're using one document and I'm using the same document, we're ultimately talking to the same server. So our connections might be to different IPs. They might be going through some routing on Figma's end, but ultimately, we are talking to the same process on the same server. So one of the things that we've done at Drifting in Space is we've kind of generalized that architecture. So we have an open source project called Plane that you can kind of deploy that type of infrastructure on your own machines. But what we realized is that a lot of people wanted to use Plane for things that were really just these kind of group chats, like just these kind of message passing types of applications. So we kind of went back to the drawing board and looked at what we would build if that was the problem we were trying to solve for exclusively. So now we've come up with this thing called DriftDB. We open sourced it a few months back. We've had some really good reception on it. And so it basically is that group chat server. So it's hosted on Cloudflare. So it's built to be multi-cloud and multi-platform. It just turns out that Cloudflare has the most robust platform for this type of thing on the edge. So we've totally embraced the edge compute aspect of this. And so an example of why that matters is if you're just using this server backends to kind of create these connections between a small number of people, you don't really want those packets to have to cross the Atlantic to go to a central server or anything like that. So taking advantage of Cloudflare's edge network, what we can do is spin up these servers close to the users so that they're as low latency as possible. So that's DriftDB. That's kind of the thing that we built. That has nothing to do with React yet. It's basically this group chat pattern for your application, where your application can kind of open a WebSocket connection, talk to other users who are in the same room. The infrastructure is taken care of mostly by Cloudflare, actually, not really DriftDB. But one of the things we wanted to do with that is build ergonomic React hooks to kind of see how far we could push the developer experience so that we could really make these types of multiplayer things less complicated. Because when I looked at a lot of the other multiplayer kind of off-the-shelf things that you can do, my mind would just melt, and I would just be like, why can't I just use set state? So you've probably all seen set state, so I don't really need to go into like what set state is, but this is just an example of a controlled component, a slider. We're calling set state. This has nothing to do with multiplayer yet. This is the multiplayer version. So what we've done is we've imported useSharedState from DriftDB React. This is our React binding library for DriftDB. And then we just changed useState to useSharedState. And then we had to add this little key. So this is saying within the room we're in, and I'll get into how we've connected to the room in a minute. But within the room, we need to kind of attach to some value. You can kind of think of it like DriftDB here is acting like a key value store. So we're kind of attaching this slider to the slider key. This can really be any string you want as long as every instance of your application is using the same one. If you wanted to have multiple sliders, you could pass that in as a prop, and then you kind of have multiple sliders interacting with other sliders. It's your application, do whatever you want. So yeah, this is kind of the important line here is this useSharedState. I should have highlighted that earlier. Here's a quick demo. This is actually a demo of the code you saw in Replit. So I just kind of copied and pasted that code in. Replit actually hosts your site, which is kind of cool. So you get like this URL, so you can open it up side by side. And even though this is, obviously this is the same machine I'm recording screen next to screen, but it really is going to the edge when I move the cursor. It's going to the nearest Cloudflare edge server and doing that. There's some limitations of doing something this naive. There are two big ones, really. Race conditions are one, and I'll show you an example of what that looks like. The other one is that we're frequently sending the entire state. So if the entire state is like an integer between 1 and 100, as it is for a slider, nobody cares. But if the entire state is a Figma document or a voxel like world or something like that, you run into trouble. You're choking the network. So that's not great. So here's kind of like a network diagram of what I mean by race conditions. So initially, we have an empty list. The server's sending this empty list to both parties. Bob pushes to the list. And we're just, like I'm using a list of numbers for compactness, but you can imagine this being like a to-do list. And Bob is adding his to-do. Or maybe it's a grocery list, because that makes more sense to share with two people. So Bob is adding cheese, and Alice is adding bread. So they're both pushing to the list, but when they push, they're just modifying their local version of the state and then sending it to the server. The server gets Bob's state and is rebroadcasting. And remember, this is like a group chat, so everybody gets every message, even the messages they sent. And this is the problem here. So Alice pushes before she has Bob's state. So she's pushing on what she thinks is an empty list. But that's if she had all the state, it's not an empty list. So her change is actually overwriting Bob's, or it's erasing Bob's. And it's really just a matter of luck or a matter of timing for her that, for Bob, really. Bob's the one who missed out. So it's a matter of timing for him that he just happened to add that at the wrong time, that it got overwritten. So this doesn't work. We can actually solve this without leaving this kind of nice world of React state management idioms and hooks and things like that. So we can still have an analogy to a React hook. It is a bit more of an obscure hook. Some of you may have used it. But actually, by show of hands, who's used useReducer? OK, so yeah, it's about half the room, third of the room. So it's not that obscure. It's also Redux, I guess, was where I first encountered reducers, and I think React kind of just picked that up. So this is sort of an example of what this could look like with use shared reducer. So just as we have use shared state for use state, we have use shared reducer for use reducer. We define an action type. Since this is TypeScript, I like to write out what the interface looks like. Basically, we're managing a list, so we have push and pop. I didn't go all out on the list management features, but the important thing here is, well, first of all, that we're operating on a copy of the data, on the copy of the state, which is just a hook React reducer kind of assumption. We implement the action, return the new state. So another kind of phrase for this or term for this, especially in the context of multiplayer, is state machine synchronization. And then to use this, we kind of use it like useReducer. We get a state and a dispatch function. So the dispatch function takes an instance of our action. So we can, for example, push 5. So to run through what this looks like now, we have the empty list. We have a confirmed state and an optimistic state. So the optimistic state is the state with the local changes applied before we hear it back from the server. And that just allows UI to kind of feel instantaneous. We actually do this on the state side as well. I just didn't show it in the diagram. So Bob pushes 5. Alice pushes 8. Bob's change is rebroadcast. Both sides now have the confirmed state of 5. This actually, depending on the implementation, but we'll say it overwrites the optimistic state on Alice's end. The server then rebroadcasts Alice's change, and now both sides have the same state. So in both cases, both the broken one and the fixed one, this confirmed state was consistent among both. So this wasn't a consistency or a correctness problem. It was basically a problem of our intent. We intended for Bob's change to persist, and it didn't. I guess you could argue that is a correctness problem, but I'm going to show you another quick demo of this. This is a counter. This is like the common reducer demo. This is actually based on React's docs for user reducer. So we just import it. We've got our count function. If action is increment, we increase. If it's dec, we decrease. Yeah, you've seen all this. We're going to add some buttons and a span. And so this demo looks like this. Very basic, but you can see we've done this. And it's hard for me to demo on one machine, but there's no race conditions here. It's all resolved. To the question kind of like, what about where these rooms come from? Is everybody always in the same room? The answer to that is we have this provider called a DriftDB provider. So this uses React's context. When you wrap some code in this DriftDB provider, everything within that is able to use database hook to get a connection to the DriftDB database and is able to then create subscriptions and things like that. What the provider does is you can pass it in a room ID. So if server side you want to figure out some room ID and do your kind of rooming that way, maybe somebody opened a document and you want to stick them in a room or whatever, you can do that. But to make things very easy to get started with, what this does is if it finds a room ID in the URL, it'll connect to that room ID. And if it doesn't, it will connect to the server. This is like the local dev server that we ship. It can connect to the dev server, ask for a new room, and then take it back and stick it in the URL bar. So then if you share that URL, somebody else is in the same room. We also have a hosted instance of this. So you can actually go to gemsocket.live, you put in your email, you get a key that looks like this. And you can expose that on client-side code. It's not like a secret key or anything like that. But that allows your client-side code to spin up these instances. You can use it in development as well. Yeah, it's hosted on Cloudflare. But again, it's all open source. You could actually take the code that we're running on Cloudflare and run it on your own Cloudflare account if you wanted. Or you could take our dev server and turn it into something that you could run off of Cloudflare. So I've got a few quick demos here. Oh, I need to, let's see. OK, this works. OK, so the first one is, this is state sharing. What I'll do is pull it up here. So this is basically the use shared state style state sharing. So this is just a few components that I've hooked up here. And yeah, someone else joined. So yeah, you can see multiple people can join. And it's kind of hard to see. We make it kind of faint on purpose, but we can see the latency here. I can actually click in and look at a UI to kind of see the messages going back and forth. I'm going to redo this UI shortly, so I don't want to dwell too much on it. So that's that one. This is similar to the counter demo that I showed. So this one is, maybe someone will beat me to connecting to this one. But yeah, you can count. The nice thing about this kind of state machine synchronization model is you can do things like turn-based games very easily. The turn-based game ends up being basically like, this is a reducer function. The entire game of tic-tac-toe is written in this reducer. Each click to the game sends that, I'm trying to play here, and this is who I am. And the reducer will say, OK, you're the right person. It's your turn, or it's not, and update the board accordingly. I shouldn't have added a reset button. Another one I want to show here. So I mentioned early on, like, you can't connect directly from one browser to another, which ends up being like mostly true. But there is WebRTC, where we can go and so in this case, these two browsers are talking to each other directly. And so you can see, yeah, WebRTC latency, 0 milliseconds. So that's because WebRTC is able to kind of figure out the closest path between the browsers, if they're on the same network, that's like the router, or it might even be loopback. So you can actually get zero latency. In practice, you have, if there's two different people, even on the same network but different machines, there's probably going to be a little bit of latency. But you can see, and then we've kind of estimated the latency here of going through the cloud. Usually, I find this Wi-Fi adds a little bit of, guest network adds a little bit of latency here. Usually we see latency under 100 milliseconds. And then we have our shared canvas here. I don't think this one's going to work well on mobile for you guys, but you can kind of, this is like, so you can draw squares and move them. So it's basically Figma. Where's our 20 billion? So yeah, so that is that. And if we go back here, yeah, that's all from me. So I have my Twitter, our company Twitter. Feel free to email me. I do a newsletter about browser tech, so like WebGL and WebAssembly and stuff. Slides and also links are on that QR code. And that's all from me. Thank you.
Okay, give it up for Paul. Very nice talk.
Thank you.
I played around with something like that a little before. I had to do it the manual way, so this would be a whole lot easier. We're going to get set up here for a little chat, little relaxation going on here. So while we get that going, I need to find my place so I can tell you what we're going to do. Okay, so yes. So our final session is going to be a conversation tonight. It's not going to be what you've seen so far tonight with the demos and the talks. It's going to be simply a conversation. It's going to be with the member of the Google Chrome team. So please welcome back onto the stage, Ben. And our guest is going to be Hussein Jerde. So please come into the stage. Give him a big hand.
Okay, I'll wait. Got to turn that on.
I think I turned mine on.
Hello, testing.
I did.
All right. Hello, everyone. Good to see everyone again. I'm extremely pleased to be joined here by Hussein Jerde. He's a senior software engineer at Google working on the Chrome Aurora team. And he blogs at web.dev, which is a fantastic software educational resource that if you haven't checked out, I would encourage you to check out. He joined Google in 2018 as a developer advocate and serving in that role until he transitioned to senior software engineer just last year in 2022. And Chrome is unquestionably the leader in modern browser tech. And Hussein has been a dedicated steward of that technology for a number of years and the community. So I'm especially delighted and honored to have Hussein here today. So welcome, Hussein.
Thank you. Thank you. I'm very happy to be here. It's my very first fireside chat. I've done a lot of talks at conferences, so I think this is great. I want to have fun, so I appreciate you inviting me.
Absolutely. It's absolutely my pleasure. And we did have 3 talks just before this, and our time is brief. So I want to jump right into the conversation. I'd like to start with the Chrome team's goal. The stated goal for Chrome, at least from a blog post that I read, is to make the web better. It's a broad goal, ambitious. Can you give us a broad overview of the principal methods that the Chrome team leverages to make the web better?
For sure, yeah. Yeah, I think if we wanted to characterize or describe our mission in one sentence, I think exactly what you said is right. Chrome wants to make the web better for you, right? For the user, for the developer, for anyone using the web. And there are a set of core principles that everyone in Chrome kind of follows. One being that we need Chrome to be fast, right? It needs to be speedy. And that's one of the differentiators of what made Chrome special when it first came out, right? Like it was a very fast browsing experience. Another that it needs to be secure, right? As a user, if you're going on Chrome to do your banking, to do anything private, you want to have confidence that the browser is making sure that everything you're doing is in a secure environment.
Absolutely.
Right?
Yeah.
The third would be simplicity, right? I think another differentiator of Chrome when it first came out years ago was that it was very simple to use. There's so much inherent complexity in the engines, right? In the JavaScript engine, in the rendering engine, in the layout engine. But as a user, you're not exposed to any of that. You're using the browser, you have the most simplest process, and that's the main idea. And then the fourth one would be stability. As a user or a developer, you would expect Chrome to always give you the same type of behavior. You wouldn't want to log into Chrome or use Chrome on a different day and just see different behavior on your web, or even if you're like working on certain APIs, expecting those APIs to change. So the fourth pillar would be stability, right? Chrome needs to stay stable. Even though there's so many changes happening behind the scenes, it has to be stable. So those four principles are kind of like the driving forces of every effort that happens in Chrome, whether you're working on the iOS version of Chrome, the desktop version, whether you're working on the metric side, everybody on Chrome essentially is doing something to improve one of these core pillars.
Very good. And it seems like the Aurora, which we'll now move into in our conversation, is downstream from these core principles. And Aurora was was announced at the, well, let's back up. The Web Framework ecosystem and Aurora, which are basically the same thing. So at the Chrome Developer Summit in 2019, you announced on stage alongside, if I can get this right, Shubi Panikkar, the Web Framework ecosystem. The Chrome team would start working directly with non-Google web frameworks. And in 2021, you gave this project an official name, Aurora. So let's start with the early days of the Aurora project, then called the Web Framework ecosystem. Why did the Chrome team decide to start working directly with frameworks?
Yeah, I think that's like a main question that we get, and it's a very good question. Like, why is there a team in Chrome working with other tools that aren't, built by Chromies or Googlers? So yeah, we had a lot of ideas very early on. We had a lot of names, Web Framework Ecosystem. One of our names was Web SDK. And then Aurora kind of, I think, was a newer name that we kind of used for our internal and external branding. So I can kind of give some context of when I joined Google, and maybe I think that will give some more background. So I joined Google as developer advocate, like you mentioned. I was in the web team under Chrome. And before I joined Google, I was always using frameworks. I was always using React. I was using a lot of Angular. So even though I was under a team that wanted to improve performance for the web, I always had a framework standpoint, right? Like, what can developers that use React do to make sure their sites are fast? What about developers that use Angular, and so forth? While I was doing that, I think a lot of the things, and this still happens to this day, right? Like, developer relations is super important. How do you tell developers about newer APIs that come out in the browser, but also how they can keep using the tools that they use to make sure they're shipping good experiences? And then I think myself and a few other people, Shubi being one of them, Nicole Sullivan, Adi Osmani, a lot of people in Chrome had this sort of idea of, we tell developers a lot of the time what they need to do, right? What about actually improving the tools that they use? So a lot of people in Chrome do a ton of research on the web, right? Like, we try to look at how many sites are using React, for example, right? How many developers are using tools like Redux or libraries? And if you look at the sheer number, it's huge. Like, the ecosystem is massive. So we've come to the realization that there's always going to be a focus for developers that they want to use tools to make the developer experience better, right? So how can we make sure that the tools that they use is even better to a point where they don't need to think about all these new APIs to improve performance or security or anything, right? I think of it as, in an ideal world, if the work that we do in Aurora is perfect, we wouldn't have to tell developers about what they need to do, right? The tools will do it for them automatically. Yeah. That's a very long process. It's going to take a significant amount of time to get there, but I think that's the ideal scenario. We had a lot of early ideas. One thing that we thought of was, should we ship our own framework? Like, should we create a new one that we think has all the right developer experience and user experience hooks automatically? We thought about even open sourcing some of the Google frameworks internally. And then we thought, instead of trying to do and create a brand new framework for developers to use, why not tap into existing tools? So then we did some research. We very quickly found that React had the larger share of the framework ecosystem, and then a lot of meta frameworks or wrapper frameworks. I think there's a lot of different terminology here, like Next.js, Gatsby, Remix, and so forth. They were doing a lot of the things that we told developers to do. You should server-side render your routes. You should try to ship as little JavaScript as possible. You should think about lazy loading things, right? So we made the decision that instead of trying to create something new, we'll try to improve the tools that already exist, and that kind of started our relationship with the React and the Next.js teams.
So when we're talking about frameworks, we're not just talking about what we think of frameworks as React developers, like Next.js and Gatsby. We're talking about the core libraries themselves. React, which to this day claims not to be a framework, but let's assume that falls under this definition of framework. So you're working with the React teams directly, you're working with the Next team directly. Can you tell me about the other teams you're working with and the other frameworks?
Yeah, we work with the Angular team as well, even though Angular is a Google framework. But the Aurora Chrome team is a separate entity, so we try to work with them to the best of our ability. We have conversations with the Vue team. We also meet with the Nux team quite often. So I think the actual way to describe our work is we want to improve open source tools. Whether it's a framework, whether it's a UI library, I think all of that doesn't necessarily matter initially. It's the idea of if developers are using tools, how can we improve those tools so that they automatically get the benefits without worrying about any additional overhead. That being said, we found out that the best way for us to actually ship these optimizations is on frameworks that have more control of the entire stack, right? Like you mentioned, React, a lot of people refer to as a UI library. It's a lot harder trying to ship something in React that you want to get a lot of adoption, right? Either we can ship a plugin, we can tell developers, hey, we have this thing you can npm install. That's one route. But a lot of developers also just like using things like Next.js because it does a lot of these things automatically, right? So even though it has more control over the whole stack, we can try to improve that so that developers, when they're already reliant on a tool that does everything, they can get all these optimizations automatically.
Absolutely. So you're working with frameworks to improve the web. What is your benchmark? Is it all about core web vitals?
Yeah, so we're a very small team, and there's a lot of things we can improve. So we definitely wanted to start with performance being one of them. Like how can these frameworks automatically just get better performance? And then there's a whole separate discussion of how do you measure performance, right? And then, like you mentioned, Web Vitals is a set of metrics that a lot of people in Google and even externally use to describe how performant a site is. And then Core Web Vitals is a number of these Web Vitals, and they give a good holistic umbrella of how performant a site is, right? Like how fast is paint, how quickly can actual content render on the screen, how much are things shifting? So there's a layout shifting, that's another metric. And then how fast are things being interactive when you click on something or interact with the page? So these three are kind of the descriptors for Core Web Vitals, and we use that as a benchmark, right? Like any of the work that we do, can we accurately say, okay, we've shipped something, and developers are now seeing better Core Web Vitals, and then again, the ideal way would be for them doing absolutely zero work. There's always going to be some instances where they'll need to do something, they'll need to opt in, but we try to minimize that gap because developer experience, we think, is a really important thing to actually get better user experience.
This is extremely interesting. How exactly are you working with these teams, these companies, these open source communities? I mean, it's a whole ecosystem, multiple companies. Some of them are driven by specific companies. Of course, Angular is driven by Google, Facebook drives React, et cetera. So how does that relationship actually work? Talk to me about how that works.
That's a great question. So very early on when we decided, okay, we're going to try and improve existing frameworks instead of trying to ship anything of our own, we reached out first to the Next.js team, had a number of meetings with them. We were very pleased to see that a lot of our goals align with their goals, right? They, among other things, want to make sure that Next.js is a very performant framework for its users. And a lot of the ideas that we had, they shared, right? They were like, okay, we want to make sure that anybody using Next.js has minimal overhead and they get all these performance optimizations baked in. So that was a good start. And then we had more and more meetings. Now we try to meet at least once a week. We've had a long, I would say a couple of year relationship with them. And I think what we try to do, and we've made mistakes, we're not perfect, we try not to step on their toes, right? Because at the end of the day, they have their own milestones, right? They have their own things they need to work on. And we never want to make it seem like, okay, here are these set of engineers from Chrome coming in and telling us what we need to do, right? Like that's a bit of a slippery slope, right? Because we never want to come off and give that impression that here are a number of Chromies telling us what we should be doing and just breathing down our necks. So we try our very best to understand what their roadmap is. A lot of the times they'll share what their thinking is. Even if they can't share exact specifics, they'll kind of tell us overall what they're trying to do for the coming year. And then we'll share exactly what we want to do. And then we'll try to find things that align, right? A good example could be the image component. Alex, one of the engineers on our team, had the idea of, okay, what if there was a component that could automatically optimize images for you? So we actually had the conversation with the Next.js team quite a bit. He wrote a number of design docs, we iterated on it, and then we both had the shared idea that, okay, this is a great thing, let's work on it, right? And at the same time, while we're doing all of this, we also we try to be aware of all the newer APIs that come out, all the newer direction and things they're doing. For example, Next 13, the app layout, the app directory layouts, right? So whenever we're shipping features, we also try to make sure we understand exactly what's happening behind the scenes because A, it should fall seamlessly with their existing tooling. And we never want to ship something that wouldn't work with, say, a new version, a new feature in a version of the framework. So we try our best to just mold ourselves into their team in a way where we're helpful, but it's always a working process.
And I want to focus on that process for just one more question. Is there a project manager that is driving this? Is there a backlog? Like, how do you prioritize these features? I'm just very curious about how this is working with one meeting a week. Is it like that with all the other teams?
It depends on the team. So with the Next.js folks, we'll try to have, and this has changed, right? Like a lot of the times we'll try to just improve our process. They'll give us ideas, we'll give them some ideas. So we have a shared channel, a Slack channel. We'll just talk there about anything we need to do. And then we'll try to have now at least sort of high-level monthly syncs. Think about, okay, just high-level direction. What are you guys working on? What are we working on? Is there anything we need to stay aligned on? And then we'll have smaller syncs with specific folks in our team and specific folks of their team, right? So one of them could be, let's say, third-party script mitigation, right? Like, how can a framework like Next.js mitigate third-party impact? So we'll get somebody from their team that's actually kind of involved in that space. Someone in our team will discuss, we'll share ideas. And yeah, so I think to also answer your question, we try to also very early in the year share our goals and like a roadmap and our OKRs will say, this is what we're thinking of for the year, right? We'd love to see this land for the React ecosystem. We think, for example, Next.js is the perfect place to land it. Maybe here's a very rough idea of how it could look like. And many times they might just be honest and say, no, that's not the right direction. Let's think about it another way. But the one amazing thing about working with the Next.js team is they're usually very supportive of newer ideas, which I think is great, right? There's so many people using the framework. It's very easy to make mistakes. We have shipped things where we've had to realize, okay, maybe we've got to roll back something. Maybe the API isn't perfect. But they're very responsive to ideas, which is a good start. And then as we come up with new ideas, we'll reiterate when we need to.
So it's really about finding an equilibrium between the features that you want to build from all sides of the aisle of the feature or the improvement or whatever it is that's being built, and then just finding alignment there and just working directly on the open source projects, because these are all open source projects.
Exactly.
Right? So it's not like you're in a back room like working on the next greatest thing.
Exactly.
Interesting. What was I going to say? I can move on to my next question, but I had a really good one, really good follow-up to that. Let me move on to the next one.
I'll come back to you, hopefully.
Yes, features. How much of this is actually focused on features and building new features for the web, like the image component, versus other metrics?
Yeah, I think the majority of our work, I would say, will be described by the features we ship. And sometimes, so again, the best way for us to ship a feature is for them to not even need to opt in. It's something where if they upgrade to the later version, they automatically get the benefits, right? So that's the ideal scenario. And then there's other times like the image component where they'll have to import something to use. But again, we try to keep that low friction as possible. So the bulk of our work are feature driven, right? We'll have these high level goals in Chrome, high level things, and we'll be like, okay, how can we mold and make this something that works in the framework, right? How can React developers use this? Is it a hook? Is it a component? Is it a library they need to import, right? So like that's the kind of thinking we'll need to do. So that's the bulk of our work. A lot of the times, we're not also doing necessarily that, but what we could be doing is, say Chrome is shipping a new API, right? We're like, hey, this is brand new API. We want developers to use it. Because of where Aurora stands in sort of the middle, right? We'll just naturally try to think about how this can work in the framework. Even if we don't try to ship that specific API, we'll let the Next.js team or any framework team know. We'll be like, okay, there's this new thing shipping. Is this useful? Do you like it? Does it not make sense? If not, we'll try to bring that back to the engineering team in Chrome and be like, this sounds great, but unfortunately, it's not going to work for the React ecosystem. Here's the reasons why, right? So we try to do that sometimes. We don't do that for the majority of our work, but I think that's also very naturally useful because while we have those conversations, we're helping Chrome engineers think about what's happening in the developer ecosystem. And at the same time, we're also letting framework authors know about what's coming out, right? Because many times they'll be shipping their features, but they might not be aware of a brand new web API that's coming out. And then, if all works well, we'll think about maybe having that API ship in a specific component or something that actually works for everyone.
Is Aurora actively working on Chrome as well, or is Aurora just a bridge between Chrome and the frameworks?
Mostly the bridge. There have been certain instances where we have shipped certain things into Chromium. One example would be we also try to do a lot of metrics analysis. So using Chrome's internal pipeline, I've helped ship ways for like Chrome to detect what framework is being used behind the scenes. Obviously, this is all behind still meeting privacy considerations. So that's something we do sometimes, but usually it's only to help us for something. So the bulk of our work isn't on Chromium, even though we're still under the Chrome umbrella, but we'll do that whenever you need it to assist our work.
And how do you determine who to work with?
In terms of like actual frameworks and framework authors, it's an ongoing conversation. We were very fortunate to decide to start working with the React ecosystem and naturally have that conversation with the Next.js team. We've had conversations with the Gatsby team. We've had a few conversations with the Remix team. I would love for us to work with all these frameworks, right? There's so many newer things coming out. Ben gave a great talk on Astro, right? There's Quick, there's Solid, there's so much. So because we're so strapped and we don't have that many members and engineers in our team, we can't naturally work with every new tool that comes out. I think every week there's something new that's on Twitter that even I try to keep up with. But what we try to do is we try to see where the ecosystem is headed. And then we'll try to actually see, okay, is there a value in us having that conversation with that specific team, right? Like Vite is a good example. It's being widely used. We've had normal conversations with them. We're trying to figure out, okay, is there anything that we can do directly in Vite? Is there something we can do on top of it? Should it stay in the framework layer? So it's usually an ongoing conversation. And it also, we try to make sure that whenever we establish these conversations, that whoever replies is responsive. And again, we don't want to make it seem like we're telling people what to do. Many times if we reach out with a request, if they don't think it's the right time, that's totally fine. We'll revisit discussion later. But we definitely, I think, reach out to more people to start with, and then we'll try to narrow down to see where the best fit is.
Do you see the team growing?
I do. I think there's definitely room for more engineers on our team. I think with everything in the tech ecosystem now, it's hard to see that growth in the near term, but I'm hopeful in the long term we can have our team being a much bigger presence in Chrome.
When you announced the web framework ecosystem in 2019, you selected Next.js as the first framework to start working with. Nearly 4 years later, as a result of this direct collaboration, what are the advancements in Next.js that you're most proud of?
Yeah, there's definitely a few features. One of them being the image component. I think that was one of the most widely received, positively received features that we helped ship. Ralph, another engineer on our team, shipped a script component. They had a very similar idea where a lot of the times folks using Next.js want to import a third-party script, right? And usually when folks think about third parties, they try to think of it as a separate thing as the core framework they're using. But we thought, why can't we bridge it a bit better, right? What if there was components that would automatically control and make sure that the script loads after the page becomes interactive? And then if you needed to load critically before the page becomes interactive, you have a prop to do so. So that's another thing that we've shipped that we're really happy about. I'm really hopeful in seeing that even evolve. I do have some ideas, and I think for the next few quarters, I'm going to try to think about ways, could developers even just have wrapper components to, like, let's say if they want to import Google Tag Manager or Google Analytics or Facebook Embed, What if there were simple components they can import and plug in and not worry about all the external details, and everything happens and works behind the scene? So that's an ongoing discussion. Gerald and our team actually worked with a few of the React folks and Next.js folks very early on server components. I think he helped with some of the direction. He had some very early ideas on where that should be headed and how it should look like. And then we've had some other things that haven't fully shipped that are still experimental. Ralph also shipped a feature that automatically, you have to enable the flag, but it automatically identifies what the critical CSS of the page is, and then actually injects that into the head and loads that first. And we think that's a good example of a feature that automatically happens, but you wouldn't have to do any necessary work. So I think that's some of our core features. One other thing that I did early on was I helped ship the ESLint plugin. So one term that we use very heavily in Google is the word conformance. And the idea was whatever tool you're using, it should give you the right warnings and the right errors at the right time. So we thought about how can that apply to the general web framework ecosystem. So I tried thinking about that in the context of Next.js. I helped ship the specific ESLint plugin, as well as just any external warnings in the terminal. So I helped around there. Very happy about that. I also want to see that evolve to some degree. So I'm kind of hopeful there. So we've kind of had our hands in a lot of different places. But we've definitely had more, I think, a number of features that received some pretty widespread adoption. And then as we continue working on Next.js, we also try to take a step back and be like, OK, this worked really well in Next.js. How can we apply this in other frameworks, and other React frameworks, as well as other frameworks in general?
Yeah, so great segue to my next question. Is there crossover there? Are you learning something from Vite and from Vue that you're bringing over to React or vice versa?
I think definitely vice versa, because the bulk of our work naturally starts most of the time with React and Next.js. But there have been a lot of things that we've tried to spread to other frameworks. We've used a lot of the learnings in the Next.js image component to ship something kind of similar in Angular called the image directive. Very similar idea, works as a directive, but the idea is if you wanted to use images in Angular and automatically get benefits behind the scenes, that would do it for you. Very early on, before we even shipped any of these features, Alex also helped out in the engineering team. He helped improve how Next.js chunks a lot of the bundles, and makes sure that you're not shipping more for the page that you need. So you're getting things a bit more granular. Gatsby folks actually saw that. We had a conversation with them, and they did something very similar in Gatsby, which we were very happy to see. So in all the work that we do, we try our best to see it spread. Sometimes it doesn't make sense, right? If something's more one framework specific, it's a lot harder to see it expand. But we always try to think of ways of, if it works very well in this one framework, chances are it's also going to be working very well in something else.
Do you see yourself working with smaller React frameworks like Remix or Shopify's Hydrogen?
We do. We've had a number of conversations with the Hydrogen team. We've met the Remix team a few times as well. I think we do. If we had more folks on the Aurora team, we would also be more embedded in all of these frameworks. But because we don't, we just naturally have to try to focus on one more than the others. But what we try to do is every single time we ship something, we'll at least have that conversation with other frameworks. We could definitely do a better job, but we always try to reach out to the other React teams and say, OK, we've shipped something. Can you see this work in your framework? If not, why? What can we do to change it? So that's something I hope we can continue seeing in the coming years. So even if we don't actually do the engineering work, at least they can actually see what we've landed, and we can help them and steer them in the right direction.
And how does your work here affect other browsers? Of course, Brave is just same thing. So I think it's going to be one-to-one, right? Just, I guess, a little more private, non-Google. I don't know. But Safari, are there any downstream effects, beneficial downstream effects to Safari and Arc and other browsers like that?
Yeah, I think all the work that we do, because we naturally work with open source tooling, right? Like we have to make sure nothing we're doing is Chrome specific. It has to work for the entire web, right? The web has to be open regardless of what browser you use. So for every single feature we've shipped, we've naturally made sure that this isn't something that's Chrome specific, right? It's an open source tool feature, and regardless of what browser you use, you should get the same benefit. There's another effort that we're also kind of helping out with. It's called Speedometer. It's not, I think, Aurora specific, but it's just about benchmarking browsers. And we're working with Mozilla and we're working with Safari on that. But I think that's just an example of if there's ways for us to do cross-browser collaboration, we will. But if we're working with the open source ecosystem, naturally, we want it to work in every browser.
React Server Components, announced in 2020, released 2022, just a few months ago. Did the Aurora team have any hand in that?
Yeah, Gerald and our team did have some input, and he kind of helped think about sort of the vision. They definitely, I think, had, like the Next.js team definitely took it and made it, I think, mostly their own. I think the one thing that he kind of helped out was the early thought process behind it. And then the Next.js team did a great job of actually thinking about how it works for the developer, right? Like when you think of React Server Components, they thought about ways of, okay, maybe you have app directory and layouts and actually having server files. So I think they took care of a lot of the details. One thing that we are trying to do, though, moving forward is as we ship new features, we need to make sure that it also works for both pre-Next.js 13, pre-app directory, as well as future, right? So I think a lot of the partners that we talk to, either they upgrade to Next 13 and they're just not ready to jump to the app directory, and that's totally fine. So we have to make sure the features we ship also work for them. But we also need to make sure that it's future-proof to some degree, right? Like the script component is one example. Sebastian from the Next.js team helped us a lot making sure that it also works for newer developers. But anytime we think of new features now, we have to make sure, okay, it actually fits into their model and it isn't something that's completely separate that just wouldn't work with server components.
I'll move on to one more subject, and then we'll open up to audience Q&A. So get those questions ready. Donovan will run around with the mic for you. Artificial intelligence. Let's talk a little bit about that. How is the Aurora team planning for this brave new world we find ourselves in? How are you integrating Bard or other technologies into your workflow now, and how do you see it being integrated into the future?
Yeah, so Google's, not Chrome, but Google definitely shipped a number of cool tools, right? Like Bard being one of them. Just a few days ago, they shipped the Palm API and Maker Suite, and they sort of announced that as well. So there's a lot of teams in Google, including Chrome, that are kind of thinking of where generative AI can move forward, right? For Aurora, it's still very early days. We're thinking, we don't have anything, I think, very concrete planned, but we are trying to think ahead, right? Like, can AI help the developer in any way? Can it help them in their developer tooling? Can it help them directly in the browser? Can it actually fit in their mold of building a site using a framework? So we're having those discussions. Still very early days. I can't really say anything as of now, but I'm hopeful we might actually do something in the near term for that.
Oh, what about that announcement that Vercel's been teasing? You know anything about that?
Which announcement? They've teased so many.
They're filming one of their new things this week, so no insights into that?
No insights on that one, even though it looks pretty cool, seeing them all sit in their room.
All right, that's it for me. Let's give it up for Hussein, everyone.
So if you have questions, raise your hand, and we'll get Molly on that side, and I can get this side.
Let's wait for the mic so we can get you on the live stream. Go ahead.
Hey, hi. I wanted to know, do you see yourself working with individual node packages, such as like React Google Maps, which is like quite independent right now and like quite outdated? So these packages which have like direct impact on Google's business and like integration. So do you see yourself like working with them?
That's a good question. I think that would depend on the context of the library, of the dependency. I think the short answer would be not usually, because it's hard to try to improve a single tool, a single library, and then try to get and see it grow in adoption, right? So we try to do things from the top-down approach of like what the framework can do so that anybody using gets the benefits. So we try to sort of put most of our eggs in that basket. The longer answer, though, is I think I mentioned this a little bit earlier, is for like that example, we are trying to think of ways of, could the framework do something where, say you needed to load Google Maps and you don't need to use a third-party library? That is something we're trying to think of, right? Like, can Next.js do something? So I think that's kind of where we're trying to focus on. And if we do that, it would be super nice if we can actually find something where, the Next.js team wouldn't have to, let's say, or any framework team, wouldn't have to think about maintaining something like that, right? Maybe we can have an external source for like how to optimize or load a Google Maps embed in the most optimized way. And then Next.js can just have the right tool chain to plug that in. So we think about it more top-down. So yeah, that's a long answer. I hope that sort of answered your question.
Anybody else?
Any other questions? Don't be shy.
Khaled, this is a really great conversation you guys are having. I'm wondering, aside from the framework in themselves, there's a lot of debugging tools or extension that they come with. Is there any improvement in those tools to improve the developer experience?
Yeah, so we also have some conversations with folks working on developer tooling. We met, I think, very recently. We also try to meet with people who work on the React DevTools extension. So we don't, I think from Aurora perspective, we don't spend too much time trying to improve those tools ourselves. We think of things, again, we try to improve the core framework as much as possible. I think if we had more bandwidth, we would definitely spread to specific tooling. But the thing I think we try to do with external tooling like that is we try to bridge them to people who work on Chrome DevTools to the best of our ability. So a lot of the times people in Chrome DevTools would ask us and say, we want to ship something or improve something that can make it easier for React developers to debug their site, right? Maybe they need, I don't know, better source maps, or maybe they need better ways to find the right line of code. So we'll try to actually bridge the conversation with, let's say, the React DevTools team. And then we'll try to figure out what's missing in either Chrome, the browser itself, or what's missing in, let's say, the DevTools extension. And then we'll try to find a solution to that. Is it a newer API? Is it something that the browser can do? Is there something that we can do to make their lives easier? So that's kind of like the degree of the work we've done there. But I can't say we've actually shipped actual implementation and features on those tools.
Hey, I'm Ben from earlier. But yeah, this has been a really great conversation. Of course, as someone who maintains a meta framework, it's interesting to hear about this stuff. And I'm kind of curious about y'all's process around making core web vitals and deciding on them. I think there's even a new experimental one around layout shift. I forget the exact name. But through your work with other frameworks, are web vitals informed by what those frameworks are doing? Are they meant to even challenge them or sort of steer them in a new direction? What's the relationship there?
Yeah, that's a great question. We're super fortunate to work very closely with the Speed Metrics team. They envision and design these new APIs. Like you mentioned, there's one still in the works for scrolling. And there's another one about interaction to next paint, which is sort of a successor to first input delay. Can it measure all the interactions throughout the page lifecycle and see how long it's taken for things to interact? So I think the Chrome Speed Metrics team will think about it from a high level, right? They're not thinking about it necessarily from a framework perspective, because it actually has to work throughout the web. That being said, what we try to do in the Aurora team is because we use these metrics as sort of our success metrics, we're very in tune to see if there's anything that's missing. And an example was, I think a couple of years ago, what we did was we found out that the largest contentful paint metric wasn't accurately picking up Angular hydrated content on the page. So that kind of helped us investigate, okay, there might be an issue with the metric, and they actually shipped a bug fix. So that's kind of an example of ways we try to improve those metrics. Because we're so in tune with these frameworks directly, if we see anything that's slightly off or just doesn't work, we'll try to bring that feedback back to them. But because they work very closely with us, naturally they'll also be very sort of up to date with what's happening and say, let's say React server components, if there's anything there as an example that needs to be measured, or is not being picked up by these metrics, we'll try to assess it from a case by case basis.
Makes sense.
Excellent question. Any others? We got one in the back over there.
Sharif here. I just have a quick question. So you mentioned working with other browsers. How do you maintain a competitive advantage while also fostering these partnerships with these other browsers?
Yeah, so the work that we do, we don't try to maintain a competitive advantage, and it might sound contradictory. But if you think about it, the work that we do, if we improve the tools developers use, and if that improves the web experience for Chrome, for Safari, for Firefox, everybody wins, right? So nothing that we do, we try to make sure that Chrome stands out in any way. And I think it's also just very natural by the work that we do. So we don't try to at all think about that in any way. We are a web team, right? Even though we fall under the Chrome umbrella, we think of ourselves as the web team or a web team. So all the work that we do, we try to stay and think about the open web to the best of our ability. So yeah, I don't know if I answered your question fully, but we don't at all think about that.
All right, I think about that about wraps it up. Let's give it up for Hussein again, everyone. From the Google Chrome Aurora team.
Thank you.
Excellent chatting with you. So that ends the presentation portion of the program. Now we move into the discussion portion, which will be immediately to your rear. And that starts right about now. But before we get there, can I invite all the speakers on stage and we can do like a group photo? Let's hear it for all the speakers, everyone. Molly, cue the music.
I don't know how we're doing this, but.
While you guys are all leaving, can you guys just grab all of your beverages, food, just make sure it looked like we didn't do that when we came in the space? Thank you.
There we go.
No one brought food in here.
Oh, wait.
No, no one did that.
Okay. You guys in frame?
Come on, yeah.
Yay.
Say react.
All right.
Cool.
Cool. Thank you.
Thank you. You gotta send me some of those.
Yeah. Cool. Thanks, everyone. We will see you out
Okay, yeah,
there
so
in
the way it works, we're not going home. We're going out in the back. And all that Q&A that you didn't get to do from all of our speakers, find them and ask them your questions out there. That's what makes our meetups unique. So thank you all for coming.